All right. Welcome back, everybody. Just real quick, check our audio. All right. Yeah, audio seem to be working. Okay. I don't usually stream at this time, but I really wanted to finish what we started doing, and so I decided to keep on streaming so that I could actually do the thing that I am gonna be doing. So let's quickly look at over here, and I just wanna kind of figure out something. No, I thought, but it's not true. Okay, anyway. So, what have we you know, stopped on? We are doing something here to do with um what? Player input, right? So player input. We said that we got this angle, we got this velocity, we got this acceleration. So what does that mean? Well, that means that for now, because there are no other external forces acting on the player, and the player is basically in full control of their velocity, which is not entirely true, they can do whatever, right? They can do whatever. And why did I not pour my water before stream? I have no idea. I'm gonna have to bore you with bubbly sounds. I don't know why. It just happened to me this way. So, actually, I'm running out of water. I have less than a liter left. Hmm. I mean, in my backup bottle, not in my main one. Actually, in total, that is about a liter worth of water. Well, anyway, um, so we tried to make the player controllable as a movement intent. And the thing about movement intent is that it is not handled here properly. We're gonna deal with this a little later. Um, so actually, can we do math? Yeah, in fact, we can do math inside of here. Hmm, cool. Nice. We can do math inside of this. That's fun. Alright. So, here's what I'll do. Um, oh, wait a second. We can't really do math. I mean, we can, but not really. Anyway, so let's see. We need to know what the handle controller thing will do. So as I have learned, based off of, um can I please? Okay, based off of this, this thing here, the y-axis, that's the sinus, and the x is a cosinus of this. What is it? Theta, I think it's called. Basically, of this angle, right? And the angle is measured in radians, and this u is equal to 1. And yeah, I believe it's a radians angle. Mm-hmm. Okay. Seems to be pretty good. Alright. Interesting. Website. I'm not reading any of that text, but they do give us this really nice thing, so we're just gonna use that. So we're gonna say that basically our angle is going to be, I'm not our angle, but our vector will be composed of a cosinus and a sinus of intent.angle, but we have to multiply them by velocity. But, but, here's the thing. Actually, none of this is true because um, we basically need to get the current velocity of our, well, actually, no. So we need to know, hmm, this might be a problem. This might be a problem. You see, what I want to do is as you move around, I want you to have a smooth acceleration, but because there is no state inside of the system, there can be state only in the components. Dang. So I need to store like two velocities basically is what you're saying. Can we not impose like acceleration on it? Actually, yes. So velocity in this case would be, we're not even gonna have velocity. First of all, we're gonna ask, is the velocity if, so we're gonna compute velocity first. It's not exactly accurate because apparently um, it's not exactly accurate here because apparently if you no matching constructor, oh yeah, sure, because like you're supposed to having the magnitude of it, but you're not necessarily increasing the magnitude of it, or do you? Does it increase the magnitude? Well, it does, but not in a linear fashion. So that means that if I want to increase it in a linear fashion, where is it increasing in a linear fashion? Yeah, actually it is, but it's just not. Um, yeah, it depends on the angle. It depends on the angle, is what the answer is. If you want it to be more like, or does it? I mean, it shouldn't. Jesus, that's hard. I mean, okay, let's think of it this way. If I want this to be twice as long, its projection is going to be twice as long on both axes, right? Yeah. So it is getting twice as long. Or is it? Yeah, it is. Because it's like taking one vector, putting another vector on the origin of where this ends, and it will be two of them because we know this length is one, and if we add another one, but this is twice, so yeah. So you don't have to think about it, okay? What I'm trying to figure out is if multiplying it by this velocity here, like this, just like this, would actually make the vector twice as long. And I don't mean, like approximate, I mean like exactly. Does this length of this arrow increase? Oh shit, I'm not showing it. Well, anyway, like I'm asking, is the length of this arrow actually increasing? And the way that I found out that it is because if you take this arrow, you put this point here, so this point jumps to about here. Because these distances at the bottom and on the side here are the same, or they're still, the same things, and because there's two of them, the double the length is going to be double this distance, so multiplication works. So we can just multiply it like this. Just sinus times velocity, and then this times velocity. And if I am wrong, prove me in the comments. Or at least link me like an article or something. I'm pretty sure I might be. Like, I could be, okay? But I seem to be rather competent that it's not. I am actually correct. Anyway, so we got this thing working. Now we can actually... So we know what the velocity should be on both axes, right? So we went from the vector... Um, we went from velocity to a vector. Now we need to do something with acceleration to make that stuff happen, right? We want to have some way of accelerating ourselves towards this speed, right? So what we can do, I'm thinking, what we can do is we can say that vector addition, oh shit, yeah, vectors are cool. Yeah, I think I now realize what a vector actually is. Well, anyway, so velocity. Wait, we have m vector in C++, I know that. Anyway, let's keep on going. We need to now know what should the velocity be in our acceleration model. And here is the question. I guess it's collisions that make that? I wonder. Getting all the physics right is going to be completely just out of my mind, but I might even make my own physics engine for that matter, because it'll make things a little more interesting for me. Well, anyways, so velocity. We need to calculate what the velocity is, and for now, you know what? Let's get rid of that acceleration. Because I'm not really willing to deal with it. I don't want, like, slow acceleration yet, okay? I will achieve it later, just not yet, okay? So, here's what we'll do. We'll just say, this is our velocity, this is what it should be, right? And I am going to say that... Oh, also multiplication by 0 works. Pretty good. So we can actually set that as our velocity, and this system should theoretically work just fine. And I want to do a little bit of interesting thing with mouse control a little bit later. We'll do that. We can make Agar.io. Yeah, we're not going to though. Anyway, so then once we have this, we need to set up player control so that it would in place this player controllable onto... Oh, wait. Well, this is going to be a little interesting. How about we pass in our player into here? That's not going to be the way. Let's, in that case, not in place a player, but instead look for those movement intent and we're gonna say we want our movement intent right there, and we're gonna say that this is our intent. And in fact, we can just use an auto in here. We can say that controller dot velocity dot y, let's see, controller dot velocity dot y. We don't want this. We want intent dot velocity to be equal to, is there a velocity there? Yeah, there is. To be equal to, say, 3, because it's what we decided. Okay. And that will be the same everywhere. Movement intent. I keep misspelling it. So we're gonna say velocity is equal to 3. However, here's the thing. We also will say that our that that our velocity, so our angle is well, we could do it with like sinus and cosinus multiplication. I'm gonna have to think about this. Okay, so the way we're gonna do it, one way is with sinus and cosinus multiplication. So instead of, finding the sinus and the cosinus, we could just set it to be, 0, -1, and all that. But that is very binary, and it doesn't allow for that 45-degree angle, right? Because you can't really, like, okay, you could compute the square root of 2. Instead, so you either compute it relative to pi, and I just wonder, like, how precise do we want to be with pi? like, would this be enough? By um, how much precision for cosinus and sinus? Because I just kind of want to know, like, how many. Hmm. Just how precise is it? Because we're gonna, like, we could make it, so that you, but then you still need this. Yeah, you still need to compute sinus and cosinus if you want to be like lazy, and not have, because here's the thing: when you move in two axes at the same time, like say you move in the vertical axes and you move in the horizontal, if you move per tick, you're allowed to move 1 unit of, some 1 unit. If you start moving in both directions 1 unit, you actually move slightly faster, which is square root of 2, I think. Let's see, 1 plus 1, square root 2, please. Yeah, you move at 1.4 times faster if you move in two directions at the same time with a offset of 1 in each. So it's actually faster moving diagonally than in the game than it is moving in a straight line, which makes for some rather interesting building techniques the player can use, and maybe speedrunners can also take advantage of it, but moving in a diagonal is faster than in a straight line. Obviously, if you're moving in a straight line, in that case it doesn't matter if you swear, because your axis aligned movement is constant, always. It's your diagonal movement that's not constant. So if you're trying to achieve a diagonal movement, then you will, like, yeah, actually you're still moving the same speed on the axes, but normalized movement is not going to be the same. Anyway, I think you understood before I explained it the second time, but the point is, you don't want this in your in your game. At least you should not. I mean, you can want to have it. I don't want it because my movement is not axis aligned. It's not on a grid. So yeah, actually on the grid, it's even worse because you're actually moving. Actually, you're moving at the same speed. Wait, no, can't be moving at the same speed. Wait, I measured it wrong. Or did I? No, I didn't. Actually, on the grid. Oh, wait. The when you're not binding it to. Yeah, actually, this is still on the grid. If you were to, if you were to, dang it, loads so long. Why does it not bring up the calculator though? That's weird. I want the calculator. Oh, there it is. So this is still FYI. It's getting close to dinner. Not that I'm gonna end stream, it's just that people are bothering me regarding dinner. Anyway, so this is basically movement on the grid, which we don't want in case we want to move diagonally. We don't want to move like snap to the grid per tick, per like physics tick. And of course, we're assuming that our movement is, well, in our case, we move in box 2D, we move in meters per second. So it's not going to be per physics tick, it's actually going to be per second, but it will still be per second grid aligned movement if we just move, one in X and one in Y, and it would not be exactly what we want. We want the actual distance traveled to be one. So, as a result, and this actually will be more noticeable with 3, I think. Yeah, look, instead of moving 3 blocks, you move 4.2. Now, you wouldn't notice it because you just move like 1, 2, 3, but the distance is clearly a lot more than this or this. Either of them, doesn't matter which. The distance is more. That's why we're cutting it about. Actually, we would have moved. So if we were to flip it, it would be, yeah. Okay, anyway, let's stop. I cannot explain this on this calculator UI. What I am trying to point out is that we need to know what the radian is, and we know the value in degrees, so best thing I can do is C++ degrees to radians, and I would love to use a standard C++ function. There should be something. Like, I know how to convert. I could Google the math for it. I just want to know. Oh, that's a good one. Is it in my playlist? Where is this song? Oh, it's not. So good. Yeah, we're vibing. Oh, they're using A cosinus? Arc sinus? Arc cosinus? I forgot what that was. I think it's like the other version of sine, like it's like an inversion of. I forgot what it is. I haven't done the math in a long time. Anyway. Dun, 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 dun. Get degrees. Const double half c equals pi divided by 180. Double input c in input. Return input times half c. How precise should it be? So converting the angle x degrees to radians is 2 times pi. This is what we need. And if you know how to do math, so you're gonna want to basically what you would want to do, in fact, is intent that angle equal. There is a standard Neighbors pi. Oh, that is so good. Oh, that is so good. That is so good. So good. Okay, so as we have learned, it is basically 2 times. Jesus, what else is in there? Not found for pi. Okay, let's make this, I don't know, 90 for now. I just want to see the pi. Namespace numbers. Yo, that is pretty cool. What do we got here? Tab name template TP. Oh, okay. Let's see. Oh, they're using triple slash for documentation. Pretty cool. So E logarithm E logarithm 10e pi inverted pi. What do you mean? Oh, 1 over pi you mean? Okay, pretty cool. ln2 ln10 square root of 2. Oh, you can have square root of 2, square root of 3, inverted square root of 3, e gamma, phiv, e. Oh, and these are like inline const expert. Whoa, that is so cool. That is just, oh, that is just, I did not know you had this. Yo, this is cool. Is it? Oh, GNU. It's a GNU thing. But it's probably not specific to GNU. The using declaration, no, it's fine, it's fine. I wanted to be explicit. So here, a result of integer division used in a floating point. Okay, so 90 divided by 360. Of course, we know what that is. Basically, we can compute this at compile time. So what this is doing is it's saying like, hang on, I'm thinking about something. I guess it's relative to x direction, right? So I'm just trying to understand which axis is 0. I think positive x in this case is 0. It depends. It does not depend here. It depends on where you use it and how you use it. Because if you set the x to be cosinus, your 0 is going to be at x here because you calculate this angle like this. So positive x is 0. This is 1. This is positive y. This is negative 1. But actually, this is 0. This is quarter, point 0.5, 7.75, and then 1 or 0. 1 and 0 are the same. And you can have this number as big as you want because, well, sinus wave is infinite. It just repeats itself. So you could say that angle in this case is 0. And this is const expr. Okay? Not sure how to make it const expr though. Then here, I'm pretty sure the compiler is smart enough. You're gonna say here that it is let's see, this is like x, right? So this is 0, of course. This, oh, in fact, oh wait, what did I do? Anyway, just paste it in here. So here you're gonna say, here it is of course 0, as we said, because x positive is 0. Y goes perpendicular up to basically 90 degrees, and y positive is positive 90. So that will be 90 over 360, and if you, I am terrible at calculations, so let's just open a calculator. 90 over 360. That'll be 0.25. Actually, it was pretty easy. Calculations. Anyway, how did I not think of it? It's just a fraction of 1. So 0. So 0.25 f is what it is. And then because it is 2 times pi, well, okay, you're just gonna keep it this way. Or you could say that it is division by 4. But because it is times 2, you could say that it is pi over 2. So you're going basically into what you're writing down essentially is, oh dang, can we have this cool thing again? Hello? Please? Where is the circle for nerds? The nerd circle? The circle? Also, this is what I was talking about. The fact that you travel more if you're traveling on the diagonal. It's going to be faster than going this and then that, but I mean, yeah, but you don't want it to be too fast. Where's the nerd circle? Oh, there it is. Okay, this is what I was looking for. So this is pi over 2. So you know what we got. This is 0, as I said. This is going to be pi. Sorry, backwards is actually just going to be pi. Oh, I love it. It just looks like math. Yeah, pretty cool. Anyway, so you're just gonna do this and say that this is S. Oh, sorry. This actually is A. So it's pi times 3 divided by 4. And this, yeah, we could compute them precisely, but we don't have to. This would be pi times, which is it? S. Pi times 4 divided by 3. Wait, hang on. Say that again. So S is 3 over 2 pi. 3. I completely messed up. I don't know why. 3 over 2 pi. Um, and this is pi. A is pi. A is just, equal to pi. And this is, which is a D. Hang on. W is up. W is pi over 2. This is pi over 2. This A is pi. This, what is it? S, that's 3 halves pi. And this is, yeah, so basically the way it works is like half a pi times 3. And then this is, I believe, 0. Because it's D, it's positive x, that'll be 0. Yeah. Okay. Oh, I love it. A very mathematical thing. And you can specify whatever number you want, and it should be between, well, okay, it's going to be percented, basically, between 0 and pi over, actually 2 pi, right? And this should, oh, this is why I couldn't move backwards, is because I should have pressed A, because I thought oh my damn it. Anyway. I should put them in the mathematical order. Oh, player controllable. Yeah, of course. Because it is a movement intent. It will tell you none something specifier. Because it is not on something, or it is actually, but it anyway, it's true, but wait, it's supposed to be included already. It is. What are you doing? Oh, because I misspelled it. Move, move, minute, intent. Okay. Let's rename this. Movement, intent. LSP rename. Thank you. Compile. You know why people should start programming? Is because sometimes you have an issue in your code and you are literally willing to tear your hair out because you do not know why it doesn't work. And then finally, when it does work, you just explode in happiness. You know, sometimes you do get frustrated though. But yeah, handle player control. What's it saying? Handle player control. What are you? What are you? Handle. What are you? I don't understand. Dun, 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 dun. Oh, what's that? Handle player control. And is it defined? No. Do we need it? I I have no idea what this is supposed to be. Oh, a bunch of stuff is gonna recompile now. Uh-oh. Too many things. The render is gonna recompile. And then I think the physics. Because, yeah, the physics, that's the order they go in CMake file. And then it should all go, like, I have 4 cores. It should go, like, each file in separate core and separate thread. Handle events. And then main.cpp. There's like 4 files. I could have done this 4 times faster. What are you saying? Oh, like, yeah, this not declare, that's fine. I don't know what that was supposed to be. I have no idea why it's supposed to be this way. I don't bother. Alright, let's run it. Can we move now? Ha ha ha, no. Because apparently that handle movement control was doing something. Can't move at all. Well, let's see. Handle events, what does it do? Handles events. Handle keyboard keys. It will check if state is SDL pressed, then it will do that. It will say that for every view of movement intent, you're gonna set it to be, something. And then what is this? Handle control events. Oh, I think it was renamed. I think handle control events. Oh, so we are getting updates, but this is what it was. Okay. Okay, and the compiler will not tell you that you have something that's not in the header, because it assumes that it should be this way. So in that case, if I go back to my main.cpp, a bunch of stuff needs to recompile again, but I can handle events on the registry. Handle control, intents, what are you? Use of undeclared specifier. What are you? Handle control intents. What are you? What are you? I don't know, it's lagging, probably. It's the issue with the language server, I think. Because it should build normally. Yeah, I really should split up that header file in systems.hpp. Having it separate so that the renderer doesn't have to recompile when they change the physics system or the controls is quite convenient. We're gonna do that a little bit later because right now I don't bother enough. Yeah, this here is just a problem with the language server. It's not actually a real issue. You can tell it because you're good at coding, right? Don't just blindly trust your Visual Studio like plugins, which apparently are trash regardless of. Look, we can actually move now. But is it that they also we can stop for some reason? Okay, are we moving at the same? can actually collect these bottles. Okay, I think I messed up a little bit. Or did I? No, it was just tripping me up. Okay, so bi-directional stuff doesn't work, apparently. When you press the key down, it does not keep track of what you have already pressed. But yeah, we threw away all the boxes, apparently. Some of them are moving for some reason. And we can all move at the same time in both directions. Okay, because I do not, it doesn't stop moving. When I stop moving, it really trips me. Oh my god, it's trippy. This game is really trippy. Having no reference. I really should add like some texture in the background. Maybe. Maybe you should make these boxes colored and make them look good. But the issue is it's not actually stopping us after we release the key. So let's make it stop us if we release the key. We should set the velocity to be just 0 if we are not pressing any key. Also, the way it should work is, what if you press all of them at the same time? What if you just do that? What if you just press all of them at the same time? What if you just, smash your keyboard and just press all of them at the same time? And let's pretend like they are all pressed within the same SDL tick, right? So they're all going to be like, exactly just the same exact timing is going to be, right? You should not move. If that's the case, if you're going in for all 4 directions, you should not move. If you're pressing them exactly at the same time. If you're pressing them like slightly later, you might move a little bit, or you might start moving in one direction, which should not happen, by the way. It's like if all 4 of them are pressed, you should stand still. So how do you do that? Well, you could use vector multiplication. Can I like somehow ask SDL if a key is pressed? Is this key pressed, SDL? Is it pressed or not? Because we should not listen for events unless it's like text input. We should listen for we should check if the key is pressed as a boolean, and if it is, then you need to do some math in that case. But and also from here you can see you can't see anything actually. No, you can't see that the player is constantly moving. That's what you can see. Anyway, so also I should really disable this. I should put it like as a overlay. Oh, I just remembered a video about .NET obfuscation where the guy was like, so if I blind you, and what he was referring to is just a white screen. If I blind you, can I have a white? Yeah, if I blind you, you can see this. And then he was like a little bit later, oh, if I blind you again, you can see this. Oh, it's just a funny video. It was too funny. Oh, don't be this funny, please. I blind you? Okay, so the controlling system seems to be working somewhat decent. So let's just use maggot to save our state. It's maggot is like a checkpoint. Um, let's stage all these files and commit, and let's take a look at the diff real quick, just so I can kind of understand. Yep, change that. Handle player control, change for intents, basically little things. Yeah, okay. Improved player. Um, improved player. What's it called? Player control system. There you go. And so far, not so many commits, but we're getting there. Alright, so now we can actually wreak havoc on this. I should at some point set up a remote server. Because I already have it. Wait, I'm thinking about something. I think my I think my server that's right literally in my room is capable already of booting and running Git. Yeah, I just wanted to make sure I have the copy of all of this. Not on GitHub, although I should probably put it on GitHub. In fact, I will. Maybe someday. But for GitHub, you need like license and all that. If it's local and I'm just personal use slash streaming, it's fine. Anyway, so continuing on, let's see here. We are having movement that does not stop, so we should make it stop. And the way we make it stop is by making it stop. Basically, here inside of here, if oh, it doesn't even check. Oh, no, it actually does. So if SDL is pressed, you launch this loop. Um, else if e dot state equals, what is e dot state, by the way? Oh, it needs like brackets. Sure. What is this? Is this a boolean? Uint 8. So basically a boolean. What's the value of pressed? Can you like somehow? See, SDL pressed or SDL released. Please. There's multiple controller axes event. Oh, cool. Define SDL pressed and define this as 0. Oh, so it's literally a boolean value. It's just that. It's just that. It's just a, a bool. And I doubt it would change anytime soon. But we should still check it. So, else SDL released registry dot view. In fact, we should not. We should just velocity equals 0, and this does not matter at all. Like, it just doesn't. Set it to 0, regardless of the other one, it will not compute. Compile. Okay, so that not everything works. Some of them don't. Oh, because I'm dumb. Because what I was supposed to do is set this to be 0, this to be here, and I should have just copied this and did that. See how fast that was? Okay, so now you can move, and you actually stop, but you still cannot move in both directions. So how do you solve this? So for the W and S, it is pretty simple. Um, the way you solve this issue for also, I mean, it seems to be pretty reliable. Let's try to push around a few boxes. Can I like nudge it a little bit? Uh, I doubt. I mean, it does have some friction. Stop! 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 No! 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 Don't go! No! No! It's going away! No! I want boxes to stay together. No! Stop! Stop! Stop right there. Stop right there. Keep going this way. I'm a little bit faster than it is. Oh, because it's going in diagonal. Oh, it's gonna hit something. That box that flew away. I doubt it will ever catch it. Let's just forget about it. Let's just push him around. I don't know, it's fun. Still, it would be funner if I could walk a little bit faster. Then they would be able to walk a little faster. And also, it would be cooler if I could actually like move around a little better. Because pretty much as soon as I hit the other key, it completely discards my current velocity and it just starts going in that way. And unless I release the key, it would not continue going basically. So what it should do, because it's using this kind of like if keys pressed, start doing this, and then only stop doing it if the key is released. But then if the key is released, it stops doing everything because it doesn't remember when it starts doing the next thing, it doesn't remember what the previous thing was. That, oh, the boxes are gone. Makes it really hard to play. Does it even have any friction? It doesn't have any friction. It just goes. It doesn't have any fucking friction. Terrible. Well, I mean, it's working. I'm glad that I'm not yet falling apart, but we need to compute a vector that is pointing both directions and is normalized. So let's think of it. If we have currently a vector that points one way, right? Points one way. And then want to make it point slightly the other way. Um, let's think of it this way. Um, let's think of two cases, and then there should be some kind of mathematical way of computing it without if statements. I'm pretty sure. Um, let's say we're going this way, right? This is where we're pointing it. We're pressing the D key, and then, I mean, delta key, and then want to press the whiskey. I'm using the, what is it called? Um, also you, just tiny bit down. So let's say we're using delta, and then we're gonna go whiskey. This is, what is it called? Aviation alphabet, I think it's called. Anyway, so then the angle we're going at is going to be 45 degrees. All right. If we're going this way, which is alpha, then and we're going this way, the resulting vector is pointing. It's not pointing that way. Neither does it do this. It just is 0. Seems like vector addition. Well, if you consider this to be 1 and this to be 2 times pi, uh, we should keep it as, because we know the entire thing is pi, sorry, 2 pi. If we could make it like a 1, and then this is negative. It doesn't work quite the way I wanted. Let's think of it differently. Let's say we are at pi times pi over 2, and we add, or subtract, or multiply or something. 3 over pi, we should get 0, or no, we should get undefined pi value, but I mean pi multiplier for the angle, but we should get 0 as a velocity as a result. In other cases, we get just difference in the angle. Weird. It's like vector addition. Although, yeah, it is. It's like vector addition. Vector addition, for those who don't know, vector addition, geometry, please. Yeah. So vector multiplication works a little different, but vector addition works like this. It looks like triangles because it is. This is going to be a little bit more um, descriptive. This is the kind of image we are shown at the university. Um, so this is for two vector. Okay, let me. So I think this one. Let's start with this one. So we have one force. Imagine. I mean, Vsauce made a really good video about it. That really just YouTube. Let me try and find this. Okay, sorry for the interruption. That is what it is like to live in a family. Um, so I cannot find this video. There was a video by Vsauce where what he did is he had a slope. I'm not sure even if he had like a slope or something. Um, I really want to find this video though. I can't find it though. All right. Anyway, so abandoned. Um, the idea is that did I close the thing? Vector addition works this way. So it's gonna be easiest if you look at this picture right here. And this is gonna be just kind of the easiest thing to realize in terms of vector addition. So for now, ignore all of the writing, focus on this coordinate plane. Actually, you don't need this coordinate plane either. Just focus on the fact that you put a ping pong ball right here. It stays stationary. Then you kick it this way, and and then when it reaches um, and so actually it goes this ball goes uh, okay, maybe so you kick it at the same time in two directions, which I know it's hard to imagine, but imagine you kick it this way, but you also kick it in that direction, so you kick it like that away, right? So you do that, and it ends up going in this direction. And like if you kick it in one direction and it goes the constant speed, and then at some point you then kick it in this direction, and this is when you start measuring like its how it travels. Like all this math checks out in real life if you were to do it. Visas made a video about it that kind of shows it, and like this stuff works. In our case, it's going to work as you will see. Point is that vector addition works by translating vector origin to the end of another vector, does not matter which one, and the result is the origin of the first vector to the end of the last vector. So if you had, I think this one shows a little bit better. You kick it in this direction, and you also kick it in this direction. Actually, hang on, this is slanted. I know what this is. Okay, actually, don't look at that. So it works like a triangle. And then if you were to add more things, more vectors to it, then, well, it still works, right? This, okay, let's say you kick it this way, you kick it this way, you kick it this way, this way, this way. Oh, and then in the beginning you also kick it this way, and this is the result, right? And if you calculate the product for each of them, it's gonna check out to this eventually. So like you could calculate each separately, you're gonna still get the same thing. My idea is to take a unit circle and try to calculate vector addition using radial coordinates, basically, is what the problem is. So on the unit circle, have all vectors being unit vectors, and having and knowing, basically not even knowing what the okay, so it will lead to some imprecision over time. I am hoping that we can round it to, well, whatever the closest one is, right? Because we only have, what, about 8 values? So it'd be cool if we could round it to that. Um, and theoretically, we could even divide it by pi, round that to one of the eight values, and then, yeah, pretty much that. So I want to know if I could unit vector addition in radial coordinates. It's called polar. So if we go back, mouse button doesn't work. If we go back to the unit circle, let's look at, I don't know, this one. Okay, that sounds cluttered. Oh, this one seems to be good. If you add 0 to, what is it? If you add 0 to pi, you should get 0 velocity. And, well, something in terms of rotation doesn't matter what it is, to be honest. If you add 0 and pi over 2, you should get velocity equal 1, and the actual, like, what is it, angle in radians should be pi over 4. If you add if you add 0 and 3 pi over 2, you're gonna get negative, okay, well, no negatives. You are gonna get, what is it, 7 pi over 4. I think it is. Yeah, I think it is correct. Yeah, you're gonna get 3 pi over 4. Oh, sorry, 7 pi over 4. That math does not check out at all. What if you do, you know this is 0, but it's also 2 pi? Pi and 2 pi, average of that. This is getting complicated because I don't know how to solve it. Like, how do you even how do you even go about solving this? This is not gonna be reliable, by the way, because pi is not a exact number, and because float precision failure, we're gonna run into some issues. This is not the proper way of doing it. We should really look it up as in terms of like booleans. So I think the best way to do it would be to just say SDL check if button is pressed as bool. Okay, if key is pressed, actually, not a button. Oh no. Really? Do not tell me. This is obviously not the way. I mean, it is, but like, it, no, please. Oh, lazy fool. There it is. Press up, down, left, or right. So, let's see here. Oh, it zoomed in way too much. Load surface. Okay. Why would you do this? What is... I don't know. Key press surfaces. Oh, it's like key press surface up. Okay. So they're doing it with enums. Okay. Ah, Jesus. Another way of doing it. You see, I don't want to have if statements. Because if we could just add numbers, that is cool, right? That is cool. Because you just add a number, right? And there is no if statement, there's no branching. That may not be always faster though, but in some cases it will. So, as we can see, um, using the unit circle wouldn't really work unless you do some extra work to make it work, which apparently is not the best thing to do. Um, which means, oh, and also remember how I said that if you, yeah, that's just no, that's just not the way you're supposed to do it, or is it? No, fuck it. You know what? Let's probably think of it this way. If the button is pressed, you set it to be okay. So here's the thing. See how SDL pressed is a bool, and it's either 0 or a 1. What you can do is you can say that I will have a bunch of unit vectors that I will add up, and the resulting vector I will apply. How would you apply the resulting vector though? Should it be your vectors are going to be two-dimensional? It's not still in CS music. It is. Is that song Ansiasda? This is a pretty good song. Can't find it. Oh, it is. Why is it? Okay. Alright then. Makes sense. Um, so the best way of doing it would be to keep some booleans that okay, so then the function will have state inside of it, which is kind of what we want. Or will it? Because we can put that inside of a movement intent. You know what? This stream has been 1.5 hours for the algorithm. It's getting late. I've streamed for long enough today. Have a good day, everybody. I cannot think anymore. See you later, peeps. I just have to find the button again over on youtube.com. I don't have a cool creator thing that I can like, you know how you can have like C slash something. I don't have that, so I can't plug that right now. But I will see you later. Have a good day, everybody. Bye.